What is up? Daniel here with the Virtual Robotics Studio, and we are back this time for the 2025 KitBot. So we're going to have a series of videos that will take you through every step of building, programming, wiring, and getting your KitBot up and running. So for the 2025 season, the KitBot focuses on, hopefully, and if you haven't already done so, you should watch the game animation and read the rules. But the KitBot focuses on the coral pieces, which are these giant PVC pipes. So it can human load these, can start with one preloaded, it can score it in autonomous, and then it can continue scoring them during the match. And of course, you can always play defense. Now, the KitBot is designed to be a very simple, very easy starter robot. The idea is get it built, get it programmed, get it working, and then add to it. There are other things that you can do in this game. There's some hanging. Maybe you can find ways to score the coral at different levels, or you can work with some of the inflatable balls instead. So get the robot working first, and then see what you can add onto it. There are a lot of designs that will be coming out from teams who are testing stuff, prototyping stuff. There is the EveryBot. That is a group that last year added on to the KitBot functionality, but may have their own specific robot. But either way, there will be subsystems that you can look at and maybe adapt to use for yourself. All right, a couple of notes before we get started. This robot will be using the new AM14U6 chassis drivetrain. If you have one of the older versions and you're trying to follow along, there's, I think, only 4 holes that you need, 8 holes, 2 holes, 4 holes per side that you need from the new chassis to make it work. So you will be able to drill those holes if you have to. Also, we're going to be using number 10 hardware, so 1032 bolts or 3/16 rivets, which means we're going to be drilling a lot of holes using, ideally, a number 7 drill bit. So that's 0.201 inches, but a number 7 drill bit will work, a number 8 would work, a number 9 would work. If you're in a pinch, you could probably get a 3/16 drill bit to work. It's a little small, or a 13/64, which is just a tiny bit big. So we're going to basically stick to a number 7 through the whole thing. I would recommend buying, you can get like a container of like 10 number 7 drill bits for pretty cheap. So I would grab one of those. Also, before you get started, there is a material list that First put out, so check that out. Make sure you have the stuff you need. It's mostly buying 1x1 aluminum tubing, which you can buy from Home Depot or a local metal supplier. Or you can get a pre-drilled version, which is available from a lot of the First vendors. Andymark carries it. I think most of the other vendors also have that as well. You're going to need some polycarbonate, which is a plastic. Now, this is really important. There is a couple of different clear plastics you can buy at like your normal hardware stores, Home Depots, Lowe's, whatever. One of them is going to be acrylic, which you don't want. Acrylic is kind of fragile. It can crack and break. You want to make sure you get polycarbonate, sometimes called Lexan. And I think that's 0.118 or 1/8 of an inch thick is going to work. And then you're going to need some plywood and maybe some PVC for spacers. And then there's a bunch of other stuff that you're going to have to check out for bumper hardware. So there's some optional brackets, which I recommend getting. And when we get to our bumper video, we'll have all of the pieces that we're using laid out so you can see exactly what we're going to do and where you can get those pieces from as well. All right, that is about all of the preamble. So we're going to get started building that Andymark chassis. But before we do, we got to give a special thanks to Argosy for making this all possible, to First and Andymark for parts and support, and to our hosts here, Team 302, Lake Orion High School. Okay, our goal for this video is going to be to get our pieces cut down to length and then get the basic interior frame assembled. Then we'll come back in the next video, do the transmissions and so on. Now, there are multiple different orientations that you can build the Andymark AM14U6 chassis to. We're going to be using the long configuration, which is kind of nice because it means some of the pieces we don't have to cut at all. But there are 2 pieces that we do have to cut. So we have the big C-channel with kind of uneven legs. These go on the ends of the robot. This is the front and the back of the robot. We've got to cut these down to size. And then there are 2 of these long churro pieces that we have to cut down to size. Once those are cut, then we're going to be using the hardware bag. These are, I think, 1032 by ½ inch bolts that we're going to be putting together. And we'll need a few of these, I guess they're called Churros screws, but these are self-tapping screws. I think they're 1/4 inch bolts. Okay, so first step is going to be to bring the saw out. We'll mark and we'll get our pieces cut and then start assembling it. All right, the first thing we have to do is get our 2 giant C-channel pieces. And they are really long right now. They are like 31 inches. We have to cut these down to 26.5. And then these 2 churro pieces we have to cut down to 18. So let's go ahead and get these marked. let's see. You can sort of think about how we're going to cut it. So there are lots of different ways that you can cut this stuff depending on what saws you have available to you. If you have a vertical bandsaw that has, I mean, I guess what? We need this 26.5, so you need about 4.5 inches on the throat. You can mark this, and you can cut it straight through on that vertical bandsaw. If you have a horizontal bandsaw, of course, you can clamp it up and cut it. If you don't have any powered saws, you can use a hacksaw. Take your time. Just try to cut it as straight as possible. If it's a little bit crooked, it's not going to be the end of the world. And if you cut it a little bit long, you can always file it or grind it down, sand it down on the grinder. Also, if you have an electric jigsaw or sawzall, reciprocating saw, you could use that to make the cut as well. I'm going to be using a metal chop saw. So this is designed to cut metal. And these are great if you can get them. They're a little bit more expensive than like some of the other options, probably about the same as a horizontal bandsaw in price. But they cut pretty quick and they cut nice and clean edges. That said, there are wood versions of this, like miter saws for cutting wood, and those spin a little too fast. So you don't really just want to put a metal blade on those and use it. Also, the metal ones have sort of a clamp, so your hands aren't close when you're cutting the things. So keep that in mind. And I guess let's go ahead and get this marked. So I think I'm going to clamp this in this way. So if I mark it on this top surface, I'll be able to see the line when I go to cut stuff. And this says to cut from one end. So we're just going to, basically, we're going to reach out to 26.5, and we're going to try to mark a line across there. And one of the ways that we can do this is if you have a Sharpie, that is one option. So if I brought this line out, I could go to the 26.5, and I could try to mark it so that, you know, either the line should just get cut off or the line should get left on, right? So if I leave just a little bit of a mark here and I line the edge of my Sharpie up with the 26.5 line, then I'll know, okay, I'm going to cut just right to the edge of the line. That's okay. It's a little bit hard to have a very precise line. And the other thing I've noticed too, with this particular aluminum, it seems like when I put the Sharpie on, it spreads out a little bit. So it sort of bleeds a little bit into the material. So it's hard to have a nice straight line with just the Sharpie. Another thing we can do is if we color the area in. So if I use just, I got this wide Sharpie, I can sort of color the area in around where we're going to be cutting. And then I have a little scribe. So you could use, you can get one of these. This was super cheap. This is only a couple dollars, but it's got just a hard steel or tungsten carbide, some very hard material on the tip. And it's a fine point. And the idea is I can use this to scratch the line exactly where, you know, I want to be at that 26.5 inches. If you don't have one of these, if you have a snap punch or a center punch, that can work as well. It's a little bit harder to line it up on like a T-square or something like that to make it work. But what I would do is if I now come out with the tape measure, and I go to exactly 26.5 inches, I can put the scribe right down at 26.5. And so my point right now is exactly where I want the cut to be. And then if I bring a square up, make sure it's square on the edge of the piece, I can come up until I'm touching my scribe. And then I can just drag that line both ways. And so now, instead of having a wide, I mean, the Sharpie line was like a 1/16 of an inch wide. Now I have this very fine point, and that's exactly the end of the piece. Right? And so now we know from that end in, it's going to be exactly 26.5. So if I cut right on that line and not at all past it, we're going to have a very good cut on this one. All right, we need 2 of these. So let's bring the other one in, and we'll do the same thing a second time. If I put them close together, I can figure out roughly where I want to color it in with the Sharpie. So around here, I think. And we'll repeat the process. So now we'll measure in until 26.5. And then right next to it, and I like to sometimes even too, just tip the tape measure down. Make sure the tape measure is straight on your piece, because if you're on an angle, that's going to affect the measurement. There are some lines on here that you can use to sort of help guide you to make sure it's straight. But I do like to fold this down so I can go right next to the mark. And if you feel it, like when you're moving the tape measure and getting the T-square, obviously if you have more team members, somebody else could be getting the T-square for you. But if you feel the piece move, the scribe move, it's okay. Just go back, remeasure, and start over again. But it does bite in pretty well because it's a very hard material on the tip, and aluminum is pretty soft as far as metals go. All right, so we'll come back in and scribe this one. There we go. All right, so we have 2 lines on those, marked and ready to cut. So let's go ahead and get those cut here. All right, so we'll get this clamped up. And then what we're trying to do here is the line is the edge of the piece, and the side that we want is the longer side. So I need my entire saw blade to be on the shorter scrap side. And so I need to line up the edge of my teeth here exactly with the edge of that line. And that seems pretty close. So I'll make sure this is flat, and I'm going to go ahead and tighten it into my vise here. And then after it's tightened in, I'll double check and make sure we're still in a good spot. Nope, that moved. All right, so we'll slide it back over until it's in that good spot again. Let's see. Yep, that looks good. All right, so we're ready to go ahead and cut. Okay, and anytime we cut stuff like this, metal, now that we're done cutting, you can feel on the edges, first of all, there's a bunch of extra bits kind of stuck on there. Be careful with this, but if you feel that edge, if you run your thumb gently across it or finger gently across it, that is a burr. And that's going to happen every time we cut or we drill. And those burrs are going to make it so that our pieces don't fit together flat. Like if we need another piece to come on here this way or go inside there, these burrs could cause a problem with that. Also, they're sharp and they can cut or scratch you or maybe pop game elements too. So every time we're done cutting or drilling, we're going to file or deburr in some way. So we'll kind of run the file along it. Now the files generally work by pushing. And what I like to do is I like to put it on a little bit of an angle to the cut and just kind of run it along the edge. And that sort of breaks off stuff. Now the things I got on the end, you can also file across the end like this to knock off some of those. And you can feel now that I've gone through this, there's no raised edge here. That burr is gone. So I'll do the same thing on this side. Pretty good. This side. And then I'll do the insides as well. Okay, and the last thing you can do a little bit of is sometimes the corners are also sharp, and you can just sort of like run the file over the corners a little bit. And you don't even have to do much. Just if you break the corner, it suddenly gets much, much less sharp. So just a tiny, tiny bit on the corner can help. This isn't always necessary, but I'll go ahead and do it here on this piece. All right, so this one now I feel no more burrs. This is cut to length. We can measure it and make sure it is what we wanted. So if I measure this out to the end, that's pretty much right on 26.5 inches, which is what we were aiming for. So piece 1 is done. Go ahead and do the second one now. We do want to always, now there are a bunch of shavings on the saw, and we always want to make sure that the piece is going to be able to sit flat on the saw. So I'm just going to brush that off or wipe it off to make sure it's clear. Be careful if you're doing this. You don't want to use your hands necessarily because the little aluminum shavings can be sharp. All right, so we're going to line this one up. We're going to do the same thing again here. So bring this down, line up the edge of the blade with the edge of our line. Looks pretty good. Let's tighten it down. And let's cut it. Okay, and one more time, we are going to file this piece. Knock the top off, get the sides, and then the inside. And then I'll just hit the corners a couple times. All right, looks good. We can see, are they the same size? Pretty close. That's going to be just fine. Okay, and if they're, like I said, if they're a little bit long, it's not a big deal. And if they're a little bit short, it's also not a big deal. The key is there are holes on here, and we're going to use the outside holes, the end holes on both sides. So even if you cut it a little too short, as long as those holes are still usable, as long as you have a decent amount of material left on the outside to support those holes, you're going to be fine. All right, those are done. We've got our two churros here, and these we want to cut down to 18 inches. So we'll go ahead and measure those and mark those now. These are going to be hard to scribe, but maybe we can still do it. All right, so we want 18. So we know we're going to be around this area where we have to mark. And because it's not a solid surface, we just have 2 points where we can sort of try to scribe our line. And that's fine. So on this one, you probably, since you're going such a short distance, the square is probably not super necessary. Just give yourself a little tick mark right at 18. And you could try to do that on the other one as well, on the other bit of the churro that's facing up as well. So we have a couple marks there. We could then line this one up and do the same thing. So right at 18. And right at 18. There we go. So you can see this isn't as clean as the earlier one, but it's going to be more than accurate enough. And again, if you have to use the Sharpie to do it, that's fine. All right, we'll cut one of these here, and then I'll go ahead and do one example on our vertical bandsaw as well, just to give you what that would look like if you were using that type of saw. All right. Again, we're keeping the long piece, so I want the blade completely on the short side of the line. That looks good. All right, let's give it a try. And yes, even this we have to file. It's a little rough because it's got all these little holes and stuff, but we want to make sure it's going to sit flat too on the end. So if you can't get everything perfect in the little gaps, that's fine. But just do your best to knock off some of those burrs. Let's measure it. Make sure we're at 18. That is real close to 18. I'm good with that. OK, so this one's good. And then for the last one, we'll take this over to the vertical bandsaw and give you one example of a cut there. All right, so we're over at our, I guess this is a 9-inch benchtop bandsaw, but this is a vertical bandsaw. And what I was talking about was like if we had a really long piece and we had to cut in the middle, like it won't fit. It has to be smaller than this distance. We have to have one side that's smaller than the distance from the blade to the back of our bandsaw here. So we definitely can make this cut because that's much shorter. Sometimes if you have long pieces to cut and this is your only powered saw, you might have to do a hacksaw cut that's really rough nearby, and then you can come in and do a nice clean straight cut on the vertical bandsaw. Okay, everybody's saw will be a little bit different, but one thing that we always want to do is to lower the guard down until it's just above the piece, a little bit above the piece. And then we'll make sure it's not touching the saw when we start. And I'm just going to try to stay right on that line as we cut through. And by right on the line, of course, I mean the entire saw blade should be on the short side. So we want to cut away where the blade stops at the line, because the blade has some thickness. So make sure your blade is to the short side or the scrap side of it. Right, and if you have a longer cut, just take your time. If you have to angle it to stay on the line, that's fine. You don't have to race through the cut. But that looks good. We've got our second 18-inch, I guess, churro piece. We're going to get this one filed. I'm going to move the saw out of the way, clean up the table so we can come back and start assembly. All right, first thing I'm going to do is open up those hardware bolts or hardware bag, frame hardware kit that I was talking about. These are those 1032 bolts and nuts, and I'm just going to dump them into a bin so it's easier for me to access them. And we'll do that. I'll do the same thing with these ones as well. This is the churro screw kits, which we're going to need a couple of in a little bit. Now, these bolts, they're number 10s, so you're going to need a 5/32 hex key or Allen wrench in order to connect on one side. And then we're going to be using these nylock nuts on the other. And they are 3/8. We need a 3/8 wrench to fit on the outside of those. Now, really quickly before we get started, number 10 refers to the diameter of the bolt. In this case, it means it's about 3/16 of an inch. It's a little bit bigger for the hole size we want. And the 32 is the number of threads per inch. So this is a 1032 because it has, if we counted the threads on it in 1 inch, it would be 32. Okay, when we're using the nylock nuts, though, there's a couple things to keep in mind. If you look at one side of the nut, it is, let me show you a second one here. So like this one here is all metal. There's nothing else showing. It's just a solid metal on the bottom, and then we can see the threads directly. The other side, though, has a little bit of this. It's like an off-white plastic, and that's actually the nylon. And the idea is the bolt will cut into the nylon. It'll cut little threads into the nylon, and the nylon will help hold it in place. That's why it's called a nylock, nylon locking. And the problem on our robot is when you're driving around and you're crashing into stuff and you're hitting things and it's moving and you're lifting it, and like it's very not static. It's a very dynamic robot. It moves around a lot. Bolts are going to try to loosen up over time if you don't do something to fix it. So in this case, we're going to use that nylon section on the nylock nut in order to keep it locked together. But in order to use this, like if you try to screw the bolt into the nylon side first, you're going to have a really hard time because there's no threads there. It's just going to sort of be spinning on the nylon. And maybe eventually you can get it to bite. But then if you do that, it might not line up with the threads on the other side. So when we do this, we always want to have the bolt start on the metal side of the nylon, of the nylock nut. And you'll actually be able to tell. You can screw it in a few times really easily, and then it'll get really hard all of a sudden. And that's when it's hitting the nylon and starting to cut those threads. So when we go to attach stuff, almost always the metal side is going to be touching the material, and the bolt will come through the other material, and then they'll screw in together. Okay, let's start by orienting ourselves with these frame pieces. So we have the big angle pieces that we just cut. And the other piece we're looking for is this piece. This piece is weird because it has sort of the main flat section, and then it has one leg that's sticking up, and then the other leg is facing the other way. So if you look on it end on, it sort of makes like a Z shape. So those are the pieces we need. These are the inside frame rails. We have some other C-channel pieces that we'll use later that are going to be the outside frame rails. So we need these pieces. Now, just so we're all together, the top of these angle pieces is the side with 2 holes. So we have one side that has 2 rows of holes and one side that has 1 row of holes. The top is the side with 2 holes. So this is our top. And on our Z piece, I guess our inside plate, the top is going to be the side that has the smaller section in the middle. So you can see there's a wide section on one side and a little bit narrower on the other side. So this side is the top and this side is the bottom of that piece. Okay, and we're going to get one of our angle or one of our Z pieces connected to one of our channel pieces. So I'm going to hold this so that the top is up like this. And it's going to slide inside of that angle here. And what we're looking to do is 2 things. Number 1, I could attach this way, where the top flange is facing out of the robot and the bottom flange is facing in. Or I could actually have this spun around and I could attach it this way, where the top flange is facing in and the bottom flange is facing out. This way is wrong. The way I had it first is correct. So we're going to have this so that the top flange is pointing toward the outside of the robot. And the next thing we're going to do is we're going to be bolting this in to the 8th row of holes on the top here. So I can actually count the holes out. 1, 2, 3, 4, 5, 6, 7, and this is 8. So this row here, or these holes here, are the ones I'm going to try to bolt onto. So then we can just try to line this up. Sometimes you might have to twist this, and then you can sort of rotate it up into place if it doesn't just slide in nicely into position. So that works good. And what we're going to do is we're going to drop the bolts in from the top through both pieces. And then we're going to have to, from the bottom, attach our nylock nuts. Let me see if I'll spin this around a little bit so you can see the open side here. All right. So underneath here, on this one, it's really easy to just sort of reach your hand in onto the nut. And you can just sort of twist it on when it's sort of lined up in position. That one's accessible, so that's not too bad to do. Sometimes it's going to get harder to reach these places. And so one of the things I like to do is if you put the nut like right where the hole is, if the bolt is backed out of the hole a little bit, and I hold the nut right where the hole is, I can actually just twist the top to screw it in. So then my finger on the bottom that can't access anything is just holding that nut lined up, and I can sort of twist the top in. And you can see on both cases we've got the nut started on the bottom. So now we're going to switch to the tools. And the 5/32 Allen wrench goes on top, and just your 3/8 wrench goes on the bottom. And what we want to do here is we want to tighten this, but not all the way. I'm just going to get it started. And when you feel it getting tight, just stop. We want to make sure that we can get all of the bolts in and started before we tighten them down. We can also sort of tweak it to make sure it's as square as possible too before we do our final tighten down. But sometimes if you tighten it all the way, like you can see mine, while it's still loose, like you can see how much movement there is here. So we have a lot of movement on this piece. So you can imagine if I connect it this way, some of the holes might not line up. If I connect it all the way this way, same problem. It probably needs to be somewhere in the middle. But we can help find that by just basically attaching 2 bolts at a time all the way around. All right, so that was the first section in. We're going to take another one of those inside rails. And again, remember the top is this side. So top facing up. And the top flanges should be facing away from the one we just put in. Again, towards the outside of the robot. So we're going to look at something like this. And again, it's going to be the 8th hole in from the outside. So 1, 2, 3, 4, 5, 6, 7, 8. That's where I'm going to bolt. And we're going to do the same process here. So we'll get that lined up. And I will try to hold the nut on the bottom. And you can kind of see through the hole on the top too when it's lined up and feel it. And we'll start screwing that in. Now these bolts, I'm doing them in this direction because I think it's hard to get the Allen wrench in the middle, to tighten in the middle. So if I put these bolts in the other direction, The Allen wrench would have to go inside, and sometimes that's harder to reach, especially once other pieces are in place. But that's like functionally, it would work just fine if you screwed it in that way as well. So the bolt direction, usually I like to think I don't want anything big sticking outside of the robot. So if the bolts are going to be extra long or anything like that, then I would have the long bit sticking up into the robot, because outside of the robot, it can get caught on things. Or snag stuff as you're driving around, and that's not what you want. All right, so we'll get those started, but they're still loose. Okay. Then I'm going to flip this over. And I'm going to do the same thing. So the bottom holes basically are going to line up where they line up, but it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 holes. So it should be 2 holes farther in. And we do the same thing. And it's OK if you want to do these bolts going this way, because these bolts don't stick out very far if you did them this direction. So this is like the bottom of our robot. We definitely don't want long stuff on the bottom of the robot, because that could get caught on anything that we try to drive over. But like that doesn't stick out very much, so it's about the same. But I do still think it's a little bit easier to put the bolt in from the outside. So we'll do the same process of get it started. There we go. And then we'll tighten this down until it is getting close, but not tight. And then we'll jump over to the other side, and we have to do the same thing over here. All right, so everything still moves. But that side is sort of held together nicely. It's not going anywhere. All right, now we've got the other side to work on. So we'll flip it around, bring our other angle in. And it's the same situation. The 2 holes should be on the top. Make sure your 2 holes and your 2 holes are together. You can double check now before we go any farther that the shorter side is on the top for both of our inside plates. And this flange is pointing out and out. So they're pointing away from each other. The bottom flanges then are pointing in towards each other. And we can line this one up. I guess we can also find our 8th hole. 1, 2, 3, 4, 5, 6, 7. This is 8. 1, 2, 3, 4, 5, 6, 7. This is 8. So that's what we're trying to line up to. And I've had pretty good success in getting these to line up. You can do a little bit of that sort of twist on this if you have to. I'm just sort of bending it out a little bit to get it to slide easier if you need to. If it really won't go, you can tap it with like a dead blow mallet or a plastic hammer, something soft, not metal. Don't hit it with a metal hammer. But I haven't needed to do that on these for the most part. All right, we've got the holes lined up, so we're going to go ahead and put our bolts in. Also, another tip, it doesn't matter too much right now, but generally speaking, I like to start with whichever one is harder to access. So like this one, the corner one here is, or the one on the very end of the piece is probably a little bit harder to get to than the other one. So if you start with that bolt, then when you put the other one in, it might get in the way. So if I did this one first and I had to reach in from this direction, it might be blocking my access to the other one. So generally do the hardest one first, and then it will work out a little bit better for you. But like I said, on this one, it does, everything is very accessible, so it doesn't really matter. All right, got that one started. And that one is good. And then we'll go ahead and get them close to tight. Same thing for these two. Okay, then we'll flip it over. And we've got to do the bottom bolts. We can double check too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is lined up. It should pretty much always be lined up, but it doesn't hurt to count, because if it does go in twisted, if it goes in like on an angle, that's going to make all of the following steps harder as you got to put the rest of it together. Things won't line up. At some point, you'll have to take it out and fix that if you end up making that mistake. So we can check this one too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if it sort of nice and loosely fits the spot too, that's another hint that it's probably in the right spot. If it feels like you're having to force it and the bolt isn't going in easily, then definitely count to make sure. It can happen where it's in the right hole and it's just off a little bit in your alignment, and so you have to force it a little bit, but that's a good time to check. Okay, then what we can do now, and this isn't strictly speaking necessary, it's going to be pretty square no matter what we do, but I've got one of these, I guess this is a builder square or quick square. So we can measure with this corner of the square to make sure that our corners on our robot are 90 degrees. So if I come in along this edge, I like the inside edge more than the outside because the outside's got a little bit of that bend to it. But you could come in on the outside edge or the inside edge here. And the idea is if I just keep it flat against this edge or flat against this edge, when I slide it in, we're looking to see, is there a gap anywhere along here, or does it sit flat the whole way? So if you see, I think I can force this to be a little bit crooked. So now when I come in, when I hit on the bottom corner, there's this huge gap here on this side. I think I can fit like a whole Allen wrench in that gap. So we know that is very much not square. And because we don't have any tightened bolts yet, this thing moves really easily. So now this corner looks pretty square. And you can check another corner. So I could like jump over to this one and check it out. And you might get into a point where they're all really close, but not exactly square, and that's okay. The idea is just you don't want it to be super out of shape. So this seems pretty good to me. Oh, no, I moved it a little bit. All right, so that one's good. This one is a little bit that way. Just kind of do your best to minimize the error, basically. Minimize the amount of error that you're seeing. Okay, and then once that's good, once you're kind of happy with how that looks, then of course we got to be a little careful because we just went and made everything square. We don't want to move anything, but now we're going to go back through and we're going to tighten all of those bolts all the way down. And when you're doing this, up until this point, you could have been using the long side of the Allen wrench in the bolt and tightening it. It is going to be hard to tighten it enough that way. So once you tighten it as much as you can that way, you should always go to the short side in so you can pull on the long side and get some extra leverage and make sure it's really nice and tight. And now we'll go ahead and jump to the other corners and do the same thing again. All right, so this one, and that's tight. And then the other side of the robot. Get this one here. Good. And then this one here. And that is good. Okay. Let's flip it over. Because there's only one bolt in each corner on the bottom, we could still make this move if we needed to. I'm just going to check and see that I didn't make anything very out of square here before attaching the last one. Yeah, that's pretty good. So now we're ready to go and tighten all of these bolts as well. So same thing we did on the bottom. Get your 3/8 wrench on the bottom side and use the hex key on the top. And just make it nice and tight. Okay, and the other side. Okay. Then we're almost done with this step. We've got our two 18-inch long churro pieces, and those should fit very close to perfectly in the middle here. If you can't slide them in, if they're just too tight, you can go ahead and file the ends or grind the ends, hit it on one of the grinding wheels until it just barely fits. If they're a lot too short, that's okay. That's going to work out kind of fine. Well, if they're a lot too short, it could be a problem, but if they're a little too short, it's going to be okay. And these, we're going to attach basically in the middle of our frame like this, and that's going to give us strength going across the center of the frame. It's going to give us support from our two inside plates to each other, which is going to make it a lot stronger. So we got to find the right holes to attach these in. And if we look kind of on the end here, there is these two really big holes in the middle, and those are for bearings. Those are not the holes we want. If you go all the way on the bottom side to the corner here, or the corner on this side, okay? It's the same on both. There are two rows of holes on either side of that corner. So we have this row here and this row here. One of them is bigger and one of them is smaller. And you'll know that we need the bigger ones because if you take one of those churro bolts, they will not fit through the smaller holes, but they will fit through the bigger size holes. And so that's the hole we're looking for. There's those row of 3 right here, and that same row of 3 on this side right here, those 3. And we're going to put the churro in the middle hole on each of those sides. So the problem is the churro isn't just going to screw in. There are no holes. There's no threading inside the churro. And we know that because we just cut it down to size. So if I'm trying to just test this and screw it in by hand, it's not going to go. So we're going to have to use a tool to help us out here. Now, if you only have regular wrenches, that is a way to do it. I suggest using the box side, the completely closed in side if you have to. And this will eventually screw in as we're doing it, but it's going to take kind of a decent amount of effort to do it. Next, if you don't have, the next step up, if you have it, is a socket set. So what you can do with a socket is it will help you screw the things in a lot easier. So you would need a 3/8 socket for that to work. And now I can use the socket to turn it. And then because the socket ratchets, it's going to be a lot faster for me to drive that in, although it is still getting hard. And then the best option, so we'll do one this way, and then we'll switch to the best option, which is a drill or a driver with a matching bit. OK, so if we line this up and start screwing it in, you might find also that it is really hard to hold on to the churro piece when you're screwing this in. I'm trying to hold it with my hand, and at some point, it's probably going to get tight enough that I can't hold it anymore. And when that happens, which is now happening, you can hold onto the churro with a 1/2 inch wrench. So a 1/2 inch wrench will actually fit down onto the churro and lock onto it to help hold it in place. Okay? I'm actually going to maybe tip this up so I can kind of access it a little bit easier. And now we can go on that bolt. And you want to try to keep it as straight as you can when you're screwing this in. If you screw it in on a very big angle, it's going to get tight fast. But I can just sort of work on this by turning it and turning it back. And my arms are already getting tired. And this is only the first one. OK, and you can make this. You can, in theory, make this one all the way tight. And we should be able to still line up the other side. OK. Oh, that was awful. All right, now we've got the other side as well that we have to do the same thing. But I think it's time to switch to a power tool for this one. So let me go ahead and grab a couple of different options here. So you can use either a drill or a driver. With a drill, you have to be a little bit careful because it doesn't do some of the things that the driver does for us nicely. But if you have a drill and you have a 3/8 socket, you can either buy these sockets that go directly into your power tool, or you can use regular sockets, and there are pieces that will go in that this can then snap onto. So I would definitely get one of those. I think Andymark, who makes this chassis, sells little sockets that will fit for this, little 3/8 sockets that go right into your drill. So that might be something worth looking into. With the drill, we have to be careful at the end especially, because it's going to drill in and it'll just try to keep going, and the drill will eventually turn on us. But line up, you're going to have to bend the churro a little bit to get it lined up with the hole. And you could maybe even put that in just a touch by hand. Then it's just a matter of keep it straight again and just run the drill until it gets tight. And a lot of times too, what I'll do is I'll get it to where it feels like it was tight, and then you could go back and you could make sure it's all the way tight with a hand wrench. That way you're for sure not over tightening anything or damaging anything. So that first one is in. Even better than the drill, if you have one, because this is what they're designed for, is a driver. And it looks kind of like a drill. It's a little bit different. It has actually places to kind of click those bits in. And what this will do is when I'm screwing it in, if it ever gets too tight for it to make a turn, there's a little kind of hammer inside that'll back off and then hit it with the hammer. And this is really good because it helps keep the tool engaged with the part, but it'll also tighten through pretty much anything to make sure it gets all the way tight. All right, so we'll do this one now. Again, let's find the right hole. So we've got the big holes, then the also big, then the small ones, then from the crack here, the gap. My thing is upside down right now. But then we have the row of 1/4-inch holes, and we're going to go right in the middle one of that. And I do find, like, if you just get a little bit started by hand so it doesn't fall out on you, that helps a little bit. And we're going to definitely, especially if you're using the power tool, you're not going to be able to hold onto the churro piece by hand. So get a wrench on that. And then what the driver's going to do is it's going to make a lot of these clicking sounds, and that's sort of when the hammer's hitting. Okay, and that's pretty good. I think we're all the way in tight, but again, you can always check and just see by hand. Yeah, that's all the way tight. All right, and then we're going to do the same thing on the other side. And you shouldn't need the wrench now because the other side's tight, which will kind of hold it. But definitely if you're using a power tool, don't try to hold onto this by hand, because if it spins in your hand, it will hurt. All right, let's drive this in. Okay, and I think that was all the way. You do want to be careful with the power tools. Make sure you're not over tightening it, because they got a lot of power, especially the driver. It will just kind of keep hammering on it, and things will start digging in eventually. All right. This is a completed inside part of our chassis. We're going to come back in the next video. We're going to build the transmissions and then mount them to our inside plates here and here. And then it's, I think, the wheels and then the outside of the chassis, and we'll finish it up. So we're done with this video. We're going to come back to the transmissions in the next one. But before we go, we're going to give another special thanks to Argosy for making this all possible, to First and Andymark for their parts and support, and to our hosts here, Team 302, Lake Orion High School.